Hello everyone, in this video we're going to talk about section R.7, rational expressions. So the first thing that we need to talk about is, what is a rational expression? Well, any quotient of two polynomials is called a rational expression. Okay, so a quotient is you're dividing two things, okay, and polynomials generally have x in them to some power. Okay, there's a much more complex definition of what is a polynomial, but we don't need to worry about that for this class. Okay, so an example of what a rational expression looks like is this. Okay, x cubed plus 1 is a polynomial, and x is also a polynomial. So I divide the two and I get a rational expression. Okay, in this section we're going to be working on reducing a rational expression to lowest terms. Okay, and when I say lowest terms, I mean that the expression can't be simplified any farther. Okay, it should be further. Sorry. The reduction described above, okay, that the lowest terms, is going to be a lot of us using the distributive property that we talked about in section R.1, as well as some factoring of polynomials. Now, we haven't talked about factoring polynomials before, and in fact we'll go a little bit more in depth later on in the course, okay, but I know that you can do it. Okay, so I'll assume that we have some familiarity with factoring polynomials. If it's really challenging, we can work through it a lot in class, okay, and if it's still challenging then we can work on it one-on-one. So here are three examples that I'm going to work through, and then you have a your turn, and that'll be at the end of this video, and we'll talk about some more in the next video. So the first one, we'll start with number 1 on the far left here. Okay, so you're going to see if there's anything that's similar between the top and the bottom. Okay, and so you're going to work with basically two rules: the distributive property and factoring polynomials. So in this first one, if we look just at the top polynomial, we see 6x minus 6. Okay, and so we could possibly do something with that. There's a 6 common to both terms, so I can rewrite that as 6 times the quantity x minus 1. Okay, that's using the distributive rule backwards, sort of. Okay, so I pulled the 6 out instead of distributing through. All right, and it turns out I can do the same thing with 8x minus 8 on the bottom. Right, I can pull the 8 out of both, so I get 8 times x minus 1. Now, that was clever of me because I see that there's something common to both the top and the bottom. Okay, and so this is called the cancellation property. If there's the same thing in the top and in the bottom, when you divide them, if you divide the same, like something by itself, the result is 1. Okay, so basically what happens is the x minus 1s cancel each other out. I'm left with 6/8, and you can simplify that further to 3/4. Okay, so you can simplify that fraction. 6 is 2 times 3, and 8 is 2 times 4, so then the 2's cancel out, and I'm left with 3/4. All right, so that's the answer to number 1. Now we get a bit trickier. All right, 8 minus 2x, so now we're going to work on number 2. 8 minus 2x divided by x squared minus x minus 12. So first we look at the top again. Is there anything that we could possibly do here? The answer is yes. Okay, we can pull a 2 out. A 2 is common to both. 2, and then what times 2 is equal to 8? Well, that's 4 minus x. Okay, so that is sort of simplifying the top. Simplifying the bottom is a bit trickier. Okay, so this may be something that you struggled with, or maybe something that you have a good grasp of. Hopefully you have a good grasp of it, but if you don't, that's okay. All right, x squared minus x minus 12. So when you can split this up into two terms involving x as the first part of it. Okay, so that's what I'm looking for. Sorry, that is my dog in the background barking at another dog. So I have this right here. I want this. So we have to think, what two numbers add to -1 and multiply to -12. Okay, so common factors of 12, or what can you multiply together to get 12? 1 and 12, that's not going to add to -1. Okay, 6 and 2, still not going to add to -1. And the other one is 3 and 4. Okay, now, depending on where the negative and positive signs are, we can add 3 and 4, or maybe subtract 3 and 4 to get -1. Okay, so I'll jump to the answer. The answer is x minus 4 and x plus 3. Right? So -4 and 3 are the numbers that add to -1. Okay, if you add them together, you'll get -1. And if you multiply them together, you'll get -12. So there's that. So now I have, I'll get rid of these extraneous marks there. All right, I have 2 times 4 minus x over x minus 4 and x plus 3. So there's nothing really in common here. Okay, I can't cancel out 4 minus x and x minus 4. They are not the same thing. But I have to think, is there a way that I can tweak one of them to get it to look like the other one? And the answer is yes. If I take out -1 from this 4 minus x here, okay, if I pull out a -1, what I'll get, so I'm moving down here, I get 2 times -1, and if I pull a -1 out, I get -4 plus x. Okay, so hopefully, I know that's a little bit tricky of an operation there, but if I pull a -1 out of each of these, basically the signs flip. Okay, I used to have +4, now I have -4. I used to have -x, +4 now. All right, so I pull out a -1, and so you're probably thinking, well, why did you do that? It still doesn't get us anywhere. It actually does, because I can rewrite -4 plus x as x minus 4. Okay, those are the same things. Those are the same thing. So, what I really have, if I sort of simplify all of that, is -2 times x minus 4 over x minus 4 times x plus 3. And so we see that x minus 4 is common to both the top and the bottom, and what I'm left over with is -2 over x plus 3. That is the final answer. Okay, so that's number 2. Number 3. Now we have to do that factoring of polynomials twice, on the top and on the bottom. So, on the top, okay, I want, again, things of the form like this. Okay, there's an x here, an x in the first position in each of the parentheses, and then the numbers I put in here and here are numbers that have to add to 4 and multiply to 4. Okay, there are only 2 numbers that do that, and that is 2 and 2. Okay, 2 plus 2 is 4, and 2 times 2 is 4. So I factor that polynomial, and I get x plus 2 times x plus 2 for the top. In the bottom, I do the same thing. X and x. I need numbers that multiply to 2 and add to 3. There are, again, only one pair of numbers that do that, 2 and 1. Okay, so then I have x plus 2 and x plus 1. So I see that there's an x plus 2 in the top and an x plus 2 in the bottom. So I can cancel out one of the top and one of the bottom. I can't cancel out both, only one of them. So what I'm left with, which is the final answer, x plus 2 over x plus 1. Okay, so there are 3 different examples of what I'm talking about in this chapter. So for the end of this video, here's a your turn. So try to simplify this rational expression as much as possible.